Hey everybody. This is a little bit unconventional, I think, but we'll definitely try to make it work. I'm supposed to be there in person, but had a little bit of travel obstructions. So I'm pretty sad that I cannot make it there, but I'm happy that I can join you guys remotely. This is a pre-recording, so sadly you cannot interrupt me. Hopefully I'll make sense throughout the talk. So if you have any questions afterwards, I'll have some links at the end, so you can ask me anything that you want to know online. So yeah, let's get into it. The talk is called Observability for Application Deployments. It's basically has some background context to the talk I was going to have at First Self Ship tomorrow, which I also have to cancel, but there's going to be another talk about this in July. So also more on it later. And if you follow me on LinkedIn, you'll probably hear about it as well. So let's get into it. So why are my applications slow? It's probably a question that you got asked at some point by a customer, reviewing the app store, somebody complaining about it. And usually it's always like the easiest thing to say is like, it was probably your internet, or you drove into a tunnel. Were you using NordVPN and you were connecting to like Australia when you were trying to connect to their website? There's always a reason you can find. But it's never easy, and it's never an easy answer. It's always ambiguous. There's always things to be figured out. And in this talk, I kind of want to try to talk about how we demystify how do we demystify this? How do we give a concrete answer to the question, like why is it slow? And who is to blame if it is slow? Like why? Which part of the application which part of the application like lifecycle is slow? Like, is it the app itself? Is it the request that it's doing? Is it anything else? There's a lot of things that happen in between use device and the first upstream dependency. So what is in between here? What can we find? Usually it's like front end, back end. Usually the front enders love to blame the back end for it. The back enders love to blame the front end for it. And actually there's actually a reason for that, because the world looks differently for a back end engineer than does for a front end engineer, because the front end engineer actually deploys their apps to user devices, where back end engineers deploy their apps to the cloud, like very different than a user device. Of course, a website is not necessary to deploy to the user device, but it is served there, and then from there, the page will like do its request to any backend service. And also, like in this day and age, like there's a lot of obfuscations about how these things interact with each other, front end to back end, and the other way around. Like a lot of frameworks that make like data fetching easier, but what's actually happening in the middle, like it's you to really figure these things out. You have to really have like a deepish understanding of how front end and back end communicate. So what's actually happening during screen load, like what are the things that are happening in the background here? Like for example, with service render in React, like this is an example of a service render page. You can see there's not much happening here. It's just a gray box. That seems like the person is trying to access my menu, but it's not showing anything yet. That's because this is the service I've rendered version of my menu that doesn't have a menu yet. Like the menu still has to be loaded but from the client side, from the user device. So user device has to like do all those connections to all the backend services that would populate this page. And at HelloFresh, we definitely drank the get service at props Kool-Aid. We have all of our pages on get service at props. We have all of them on SSR. It's beautiful for SEO and all those kind of things, but it's not that great for perceived performance, maybe, if you really look at the details. And I'll go deeper into this to kind of explain why. But for now, like, we would also love to be like on, dynamic IO, do streaming, have like a open connection to the backend that's rendering to the backend that's rendering the front end, or a service that's rendering the front end. populate the pages dynamically, bring dependencies in whenever they're needed, but we're still stuck with good old get service side props, which again is one of those obfuscations where engineers don't really have to think about what that get service side props function is doing. It's just doing some fetches, super innocent. It's not much, but in the end, they do all the things. Like it will render some components, which those components are going to be functional when they end up in the user browser. No, because it's just HTML, CSS, JavaScript doesn't exist yet at the beginning. So there's a lot of things there that are not that clear from just using that get service side props API. So yeah. But first, let's maybe, before we jump into all of those deeper topics, like talk a little bit about who I am. So I'm Pep, or Pepijn Sanders. The suffix is just a Dutch name. You don't have to pronounce it. It's quite difficult, but you can try if we ever meet in person. I'm a principal engineer. Worked for HelloFresh for like over 10 years now. Have been saying almost 10 years for a very long time, but now we've actually crossed that line. We're a global meal kit company. So we're serving almost 20 countries. Letters sometimes surprise the people for some reason. Like, I know that some friends of mine in the Netherlands think that HelloFresh is a Dutch company. I know some people in the US that think that HelloFresh is a US company. But it's actually a German company. It doesn't sound that German a name, so I kind of understand the confusion, but, we're very global. We're in Australia, New Zealand. We serve over 1 billion meals per year, which is also a staggering number. And that's not just in the US, it's also in other countries. So probably wondering why there's this old picture of me on the left side, and it's because it has like a story behind it, and it's like a fun fact. I've basically been in touch with the internet for a very long time on like a deeper level, where I was installing dial-up connections at all of my neighborhoods. I was just going from door to door, ringing the doorbell, like, hey, do you want some internet? I can help you out. In those days, it wasn't as easy as like just ordering your internet connection and getting some modem. It was like actually quite intense. Like you had to set all this stuff up, and it wasn't that straightforward. And to plug it all in, the beeping would go off, and then at some point you had to have a page. So what's actually going on during server-side rendering? So what's making these applications feel so slow, or these pages feel so slow? We have like the flow of a customer to its downstream dependencies here. You can see that actually has go for quite some hops. Like it has to go to CDN, then to the load balancer, then to an API gateway. Then we use Istio. We would have to go to Istio to call the front-end service, and the front-end service would have to also have to go for Istio to call other downstream dependencies, but that's not that relevant right now. One thing that I can straight up note here is that if you're the customer, not all these lines take the same amount of time. Like I think if you get to this point, they probably take the same amount of time, because all these servers are like close to each other. They're in the same cluster or in the same data center at least. But if you go from customer CDN, depends, right? Like how close is the customer to the closest CDN point, or the closest CDN point of presence? And then how close is the CDN point of presence to your ELB? Very much depends on how you deployed it. So to me, it's of course like a bit of a funny drawing, but to me, it always makes more sense when I start to kind of map this to the real world, the physical world, like the one that we're standing on. Because actually we have customers in Australia requesting pages from where we actually house all of our service, Ireland. What happens there? Like it's like the internet is not magic. It's not everywhere all the time. It's in physical places. It's a physical addresses. It has to go places. It doesn't just exist next to you. It has to travel distances, sadly. It would have been nice if it would just like be everywhere all the time. But yeah, so as you can see here, like as I said, speed of light entered the chat. As you probably know, like the internet travels mostly through fiber optic, and that takes time. It does take time, and all of those, it has to go for so many different network connections. It's not instant. So what does that actually mean? How much time does it take? Well, we measure that. So in the 3D world, welcome to the real world, Neo. That didn't come out as well as I wanted. But I hope you got the reference. We'll see this. So what we basically did is we measured we put like a little sneaky little script on all of our applications. We just let it call our API gateway. And on the API gateway, we basically had an endpoint that just returned 200. That endpoint itself, we also measured latency of that. It was like sub 1 millisecond most of the time. But you can see quite staggering numbers. Like you can see here, EU to Ireland. And again, we were in quite some countries in the EU. So this is like an average. I think this was P90. It still took 350 milliseconds to get to that API gateway. Then for US and Canada, it's close to 600. And then for Australia and New Zealand, it's actually closer to 1 second. So it can be a very different experience for customers from any of these regions. And I will explain why this is actually going to be a more excavating problem than it gets worse, the more dynamic our pages become. Like we're not that dial-up connection anymore where we have HTTP 0 where just one connection was happening after the other, where we had sequential connections. Now we have many JavaScript files, many API requests, many dynamic content. So it can actually, this can snowball very easily. So this means that the cloud, as we know it, probably usually is in just one place. It's not really the cloud. It's not like if you look, I'm going to get my page from the cloud, you look up, it's like, it's there. No, it's not. It's probably in Ireland or it's in Ohio most of the time. I think Ohio is probably the biggest AWS data center. We're an AWS shop. So everything is probably a little bit biased towards that, but yeah, or like everything in my talk is biased towards that. But yeah, Ohio, Ireland, those are like the main ones. I think Ireland was like the first data center in Europe. And also funny enough, HelloFresh itself didn't launch in Ireland that long ago. We were not there for quite some time because Ireland was one of 20 countries in the world that didn't have zip codes. Now they have zip codes, so it's easier to serve our boxes there. But before some time, they actually didn't have zip codes. So yeah, as again, fun fact. But Australia was there first, so we were serving Australia from Ireland when we didn't even have customers in Ireland yet. So what does it mean that it's not just in one, that it is just in one place? So the fastest you can go from Australia to EOS1 that we measured in Amazon's network, I basically just deployed. Yeah, you can probably go faster, but I deployed like a micro or nano EC2 instance in Australia, and I deployed a nano EC2 instance in EOS1. And I just made them ping to each other. And then I measured the P75 of those pings. And I think for Australia, I came out at 600 milliseconds, which kind of makes sense. And actually, it's almost impressive because a straight shot of speed of light round trip is around 200 milliseconds. And that's so, but it's not a straight shot. It has to go through many different network connections. There are a lot of different things at play. So I think it's actually quite impressive that it's able to do it in 3 times the speed of light. And even in the cable itself, it runs at 70% of the speed of light. So it's already quite optimized. So now that we know that the server-side rendering can be impacted by this initial like delay, right? We have this empty placeholder without grayed out. We still have to do a lot of stuff. Like if you've been doing React before Next.js, you probably know these like functions from React, like React DOM.hydrate. Now I think it's React DOM. Something root. Sorry for that, but like I've been using Next.js for too long, probably because I don't even know those internals anymore. But when you get that gray page, the first thing that needs to be done is you need to take the HTML, or like first you have to of course parse out JavaScript, and then JavaScript takes the HTML, hydrates it, so it means that it loads it into the virtual DOM, and then it can start running the effects. So if you have your typical React component that does a request on its effect, that effect will only run after it loaded all the JavaScript and it hydrated the HTML. How long does that take? Well, in our case, quite a bit. So first of all, you get the page from a distance far away, for a location far away. And then from a location far away, you still have to hydrate and initialize the application as well. So for us, this, you can see also that in Australia, it was like longer, and North America, a little bit shorter. And then in the EU, like the most ideal, but still not great. So I kind of like see this time as like the functional dead space of an application, because you have like this, there's a problem that they had at Airbnb, for example, where they also use in React, where they rendered the search bar, and the search bar was basically not functional until React hydrated. So all the people like clicking the search bar and nothing was happening until the page hydrated, until it became functional, until React mounted. So they did some work to kind of like short circuit that. And also React, of course, has been working very hard to kind of like make that better with like partial hydration, server components, client components, to make that space like shorter, but it's still there. It's always there. And I think it's quite interesting to think about it, know about it, even though there's many obfuscations of the framework that make us not realize that it's there. React also has quite some nice nifty things built in, that it will like track custom clicks. So if you click on something and then, the on-click handler only gets loaded later, it will still execute a click. Allah, that's still, that works. But if you have more dynamic things, it will only work after the hydration is done. And even more if after hydration, you're only loading like dynamic content, like, certain data calls, data, or like certain data for that page. So again, for customers in Australia, this dead space took over 3 seconds. For customers in the EU, it almost took 2 seconds. And this time was taken from time origin. So that basically means after the round trip. So the round trip is still to be added on top of this. So after this initialized, we still have to get we have to run all those effects. All those effects will have to get data from somewhere. And this is actually one of my favorite graphs that I plotted like some time ago with the help of GenAI. If you can see here on the left side, I'm not expecting anybody to be able to read this, but this is like a very small snapshot of our microservice dependencies mapped out. So I basically just mapped out all the upstream and downstream dependencies, collected them together, plotted them out with D3, and this is what you got. And now you can imagine that our poor front ends have to call data from all these separate microservices and populate the page with them. We've become a lot better at that by using BFFs. Now we're also implementing GraphQL, but like for a long time, there was, I think, like 12 calls or 13 calls to populate a full page. And then after you like interact with the pages, of course, more and more calls, it's not just one. And all these round trips are like maybe okay if you're like a new customer in Ireland, but it's not that okay if you're like a new customer in New Zealand. Because every round trip adds that base latency, adds that 1 second. 1 second delay, 1 second delay, 1 second delay. Those people are going to be more likely to drop. They're going to have like a less than optimal experience. So yeah, and that's like actually one of the things that I also like, I'm like a big proponent of, like, you should always look at your metrics end to end. Like, of course, it's good to know like your throughput and your latency in the cluster itself. To see like how the service is responding without all those external factors like the internet. But you have to know how your server is responding, or how your server is acting in the real world with real users. So here's like an example of like one of the calls that has to do to populate the menu page. Here you can see that in the cluster, 200 milliseconds. Nobody's gonna bat an eye. Like you're barely gonna notice 200 milliseconds. But then if you look at the actual latency for end to end, for Australia, it's like up to 1 second almost. And then for EU, it's around 7 milliseconds. Difference is not that big, but if you do 10 of those, then that's 10 times 300. So then you suddenly, Australia is like 3 seconds slower than the EU. 1, 2, 3. Now you can notice it. And now the customers can also notice it. And the margins will even increase, right? Because if the bigger the chance that something is slow, the bigger the chance that everything else will be slower as well. So, you can have like 10 calls, one takes 3 seconds, another takes also 3 seconds, and it will just cascade. Everything will get worse if you multiply. So yeah, what does this leave us with in the end? Total random time off the menu page. This is from some time ago. So it actually got better, but I wanted it to have the shock value. And now it's around 8 seconds. So it's not even that much better, but improving. But 10 seconds to load the menu. And this was globally. So it was still impacted by, so it had all of the numbers combined, also Australia and the EU. We only started like really segmenting that at a later point in time when we saw that there was actual value there. And as I said, now it's like 8 seconds. For the EU, it's around 6 seconds. So you can still see the difference, but it's definitely, we have been working a lot to kind of try to improve this. So what do we actually do to improve these kind of things? It's like one of the classic computer science quotes. There's 2 hard things in computer science: cache and validation, naming things. So it kind of fits one of the things that we did. It's probably not naming things, because that doesn't really come with a lot of performance benefits. But like quite a long story short, because we only have limited time with each other today, I ended up convincing business that there's like a lot of value in doing like an overall on how we like connect the things together, like a customer device and all of the upstream dependencies. How do you bring all that together? Kind of like sometimes people call it co-location. How do you co-locate the services close to the user? I think you first have to start with measuring, like how long does it actually take for the user to get those dependencies. And then you can start measuring the impact, or in timeouts. That's like the easy one to measure, actually. Like if there's any timeouts, then you can say, okay, if there was timeouts and there's like a certain percent of customers that was never able to do that, that was basically a potential customer that could have converted into, they could have bought something, they could have subscribed to a new box or something, or they could have bought some new menus or some new recipes. So what did we do in the overall? So we started to move, on one side, our services, our backend services, multi-region. And in our case, that means we deploy, like in Ireland, where we deploy in Sydney and in Ohio as well. So in the US, that's like a long story. As you saw before, we have a lot of different microservices. They all have different requirements. You cannot just lift and shift them. You have to really think about, okay, how does this now work in a multi-region setup? Do we have several different databases? Do we have different services, etc.? It's going, but it's not. We need some results faster. But one of the good results that we already saw was that we saw, for example, a 47% reduction in API timeouts. So one of the critical services, which again is real customer value that we're bringing. But again, now we didn't talk about caching yet. I think caching was actually the main thing that we realized we could do way more aggressively, and especially caching closer to the customer, while keeping the dynamic nature. So what we did before is we basically, that gray page that you saw before was like a cache page, was cacheable because we didn't serve any dynamic content from there. But what we do now is that we segment, basically, we still render the page dynamically, and we do that with Vercel now, and we do that multi-region. But the page itself can then get its dependencies either like from services, across the globe, or like in Ireland, or sorry, usually it would have just two choices. It would get it from services close to itself, like in the own region, or from Ireland. Or then the third reason, or the third way to resolve it would be to get it from cache. That's of course the fastest way. So we really try to double down on the caching. Like I think any really fast app is using caching really well. HelloFresh is a very cadence-driven company. Like we have a box every week, so we can actually preemptively cache things outside of the use journey. We can say, okay, Australia is going to wake up soon. Let's like cache all the menus close to the customers there. The menu is not going to change. Maybe what they select in the menu is going to change, but it's not going to change the base menu. All these things can be pre-calculated, preheated, pre-warmed. So yeah, that's definitely one of the ways that we went about it. So just wrapping it up, we are moving our backend services multi-region to reduce its latency, global latency. We moved our frontend to Vercel, which has multi-region out of the box. And basically Vercel has like a cache instance deployed next to it, or like next to it, co-located, still in the cloud. I mean, maybe it's next to it. Could be in the data center in the physical location, next to the same server. We quite funny. But yeah, it has like low latency to the cache instance. It will like get things from the cache if necessary. And yeah, that's like we're seeing a lot of improvements there. Like we saw like page load times decreased by 50% in New Zealand. So all good from here. Yeah, wait. So thanks everybody. I'm pretty sure there's a lot of questions, or I hope there's a lot of questions. You can ask me them. You can ask me on LinkedIn. Again, there's like a whole story to this multi-region thing and the Vercel thing, which I'm going to talk about on the Vercel webinar, which is going to come out in July. I'm blanking out on the real date right now. It's quite late here, but again, thank you for listening. Hope it was helpful, and please reach out to me on LinkedIn. Thanks Callstack and Embrace for having me. And have a good day over there. And hopefully, if you're going to the Vercel conference tomorrow, have a lot of fun. And hopefully it's not too hot there, because I saw the weather prediction, and it's 100 plus degrees is not fun in New York. I know of experience. So bye everybody.